A software release is more than just lines of code bundled together. It involves separate libraries, an executable usually, an installer, configuration files, and many other different pieces. To make the software ready to run, you need an idea of all the files and executables involved to fully deploy it, as well as the environment within which all the pieces sit. You would use a UML deployment diagram to visualize these deployment details for a software system. The deployment environment, or deployment target, can be very specific, involving particular hardware devices, or fairly general, involving supported operating systems. The details on the deployment diagram will change accordingly. For example, a video game developed for Linux or Mac OS is going to have some differences from one made for Windows, and even more differences than one developed for a video game console. We use the term artifact for a physical result of the development process. For example, artifacts for a video game would include things like an executable to run the game, an installer to install the game, audio libraries to manage audio, and multimedia assets. These are created as outcomes of producing the system, and are the final pieces to be put together. There are two different types of deployment diagrams: specification and instance-level diagrams. A specification-level diagram gives an overview of artifacts and deployment targets, without referencing specific details like machine names. It focuses on a general overview of your deployment rather than the specifics. An instance-level diagram is a much more specific approach, which can map a specific artifact to a specific deployment target. In particular, the instance-level diagram can identify specific machines and hardware devices. Most commonly, this approach is used to highlight the differences in deployments among development, staging, and release builds. When you are creating deployment diagrams, it is important to use the correct notation for the various elements. One of the most important aspects of the deployment diagram is the node. Nodes are deployment targets that contain artifacts available for execution. They look like 3D boxes. Hardware devices are also displayed in the same way as nodes. The device tag on this node differentiates it from other types of nodes. In this example, the MacBook Pro node would be part of a specification-level diagram. Now that I've gone over the deployment nodes and artifacts, let's go over how they relate. This first relationship is between deployment targets. It shows that the two nodes have a communication path between them. Between nodes that are software execution environments, this relationship typically identifies a particular communication protocol. When an artifact is deployed to a node, the diagram depicts this dependency by drawing the artifact inside the node box. This also means the artifact cannot function without this deployment target. Manifestation is shown in the manifests relationship here, where an artifact is a physical realization of a software component. The player class file manifests the player component, the encapsulated unit that contains all the functionality of a player. The player class file results from compiling the player Java file for the player component. Let's take a look at a complete example of a deployment diagram. When you look at the diagram, note that there is a very distinct hierarchy of deployment targets. When constructing your own deployment diagram, it is important to complete the hierarchy. You start from the highest level of your deployment information, from application name, down to device and operating system. In this diagram, all of the deployment targets listed make sense. You have your application listed, your device, operating system, and execution environment. When you look at each of these nodes, it becomes clear exactly what environment is necessary in order to run the application. In terms of artifacts, all of the ones shown are at a very high level for our system. When making deployment diagrams, you'll likely find you do not need many components illustrated. You keep the artifacts to a selective set of the most important ones, to not confuse the viewer. That is why I showed just the game executable, rather than having many artifacts for all the components in a video game, such as player, level, and score. Also, this executable manifests or physically realizes a game component, which ultimately brings the game's functionality to life. You would use the library tag in order to denote third-party artifacts for your system, so the audio library is marked this way. Overall, the deployment diagram gives a high-level look at the artifacts, libraries, main components, machines, and devices that your application needs to run. The diagram can be used to keep track of the files and executables needed in order to deploy and run your software. The diagram can be on an instance level specific to the deployment machines you are using, or it can be general for a range of execution environments. When you complete your implementation, the final step, deployment, can be tricky. Without having a good plan for your deployment and consistency in those deployments, you are prone to system failures.